the Academic Skills Center for making this possible. I mean, like a dream come true, hundreds of people gathering to engage in statistics. Wow. Now that's a probability, well, what do you think, Pat? Statistically significant?
It must be. It has to be. Absolutely.
And here we have a roundtable discussion. Although the table and people are not depicted here in this picture, I know that we have a globe full of participants, students, and faculty. And the whole idea here is that it's a roundtable discussion. I'm going to start it off, and then I'm just going to hope that there will be others with me and joining in. So that's why there's so much space to write here. So my job as facilitator is to create, or to be part of a creative, interactive, participatory learning experience for all of you. In addition, we have some other things going on. We hope that professors and methodologists will think of building models of students' thinking when they hear what the students have to say. We hope the students in writing will be helped in writing concise research questions and choosing appropriate statistical tests. We're hoping that we'll create and support relevant, productive, and lasting insight into quantitative research. And at the end, we'll create a list of pitfalls by reflection on student artifacts. So let's begin. And what I've done here is I've included, as you may remember from your childhood, pictures where there's something wrong with the picture. So in the first one, Women in Love, a Cultural Revolution in Progress. And I don't know if you remember the sheer height report, but it was a big one. And she based all her conclusions on 4,500 replies that she received after mailing 1,000 questionnaires to various women's groups. Can you find the mistake in either the statistical report or the picture?
Sarah and I don't want to just tell you what the mistakes are. We really want you to be interactive with this and really help us figure out where these mistakes are.
So do you see one? I was going to say that it could have been the tie on the dog, but I was told that in New York that's not a surprise. So that's not the error in the picture. What about the error in the statistics? So in this one, I would say that the sample representativism is absolutely right. It's a biased sample. These questionnaires were sent to 100,000 women's groups. So that's not a representative sample for women United States.
And why is that important, Sarah? Why do we care?
Because this especially, and a good example here, Pat, Women in Love, a Cultural Revolution in Progress was used in many places to tell the rest of the world what women are thinking. And
right.
As though this were culturally what we were thinking. And if you Google the height report, I think you will be astounded because they have used it so many times, only to find that it's a biased sample.
Yeah, and especially then to try to generalize it to, other groups. If it's a biased sample, then you're really going to have a tough time generalizing it to anything outside of that really small sample.
Yeah, and I see the answers here. The picture had nothing to do with the article. The picture was for you to see that sometimes finding the error is as difficult as it is to find the error in this picture. So some of the things that are wrong is that the guy is sitting on the handlebars and riding backwards. So it was to say that many times we write what we think is a really good research question, only to find out that somehow we have missed the mark, or in this particular case, we have a biased sample.
Absolutely.
Okay. So here's our second one. Is there anything wrong with the picture that's here? It's not. It says look left, but the arrow is pointing right. So in this particular research question, what is the impact of formal learning space on student learning? So there were two groups, experimental and control, and one group was in the regular classroom and the other room was in a special space. The author conducted a quasi-experimental research to compare ACT scores which is a math scores, between students in a traditional classroom and those that volunteered to participate in an active learning classroom. Okay, one answer was not randomized, and sometimes if we use classrooms, that is true, that they won't be randomized because we don't have the option to change them. So that sometimes is a pitfall, but there are ways around that, and there's a way around these people as well. How could we compare the two different groups?
Yeah, are these two groups really, there are quite a bit of differences, it looks like, between these two groups.
And the only way that we can eliminate all the other reasons that one group may have done better than the other would have been to have a pre and post test. And do we know what we could have used, what test we could have used for that? So in here, the reason that we would use ANCOVA, and we would say the covariate was the pre-test, was that eliminates our discussion right now. We would have to say that we've made the test eliminate the difference in the group before the classrooms or the different classrooms. So if you're going to do some sort of intervention, you want to be sure that there's some way that the results cannot be because they were different in the start.
So Sarah, when you say a covariate, can you help us understand the difference, if there are any, between a covariate and a confounder? Are you really saying that it's a confounding variable, or is it just a covariate in this?
Okay. Well, I would see a confounding variable be something like research shows that kids with bigger shoes read better. And basically the confounding variable in this case is age, because we're assuming that when kids get older, they have bigger feet. So we've used shoes, but we should be using age. That's confounding. In this particular case, we are saying that we want to be sure that these two groups would have got the same scores on the act, regardless of what classroom they had got into. And the covariate is a way of leveling the playing field. Yeah, and the independent sample t-test is a good answer, but again, we would have, the problem would be is we could compare them, but the whole difference could have been they were different originally and absolutely nothing to do with the classroom. So let's see how we would fix this. We could write it as people younger than 18 years of age are more likely to watch horror movies than, and we can write than comedies, right? We could compare the movies, or we could say people younger than 18 years of age are more likely to watch horror movies than senior citizens.
That's right.
So that we have two variables to put together here.
And a lot of that, I think what you're saying is, whether that's in the research question or in the statistics itself, is just being as precise as you can be. So the more that you just talk generalities, the more difficult, especially in statistics, to really figure out what does that really mean? What are we really trying to test here? Because again, with statistics, what we're doing is we're testing these questions, using a hypothesis. So if your research question doesn't result in a hypothesis, and that hypothesis can't be tested, then you run into trouble in how you're actually using statistics.
And back to this one, when we talk about two groups, in the tutoring service, there have been people that have used logistic regression, but then have only got, say, people with diabetes or people with TB or whatever, where logistic requires two groups. So if you want to find predictors, that means that you have to have people that are yes and people that are no.
That's right.
And in here, this is the same basic example. Okay, so here's another research question and some errors that you can find, hopefully. So in comparing colleges, Seneca College is a better college than the College of the North Atlantic.
Yeah, better in what way? Based on what? So it's very non-specific. It's kind of flowery. not well defined. Yeah, what is better? What is the hypothesis? What is it based on? I think they're on the right track, Sarah.
Absolutely. Absolutely. And the errors, can you see some errors in the pictures? Like no wheels on the back of the wagon? So here's one that one way we could compare them. In comparing students from Seneca College and the College in the North Atlantic, Seneca College has a higher percentage of active alumni.
Yep.
And how would I get to this point? How would I have written a higher percentage of active alumni and in any way compared it as something being better? What would have led me down that path?
So again, you have to have, kind of a base of what you're actually measuring. What are you comparing it to?
This is good funding, like the whole, but how I would get here was I would have had to do a literature review, and that would have led me to believe that one way of comparing colleges would be on the percentage of active alumni. It might be in the number of doctoral faculty. It might be, as you say, in funding. It might be in the courses that are offered. But we only get there by doing the lit review and finding out where that's taking us. And in this case, I just made this up, but you guys have got some great examples, more involved in the community.
Yes. Yes.
Absolutely. This is great. So we've added that to our flip chart. Okay, so in this one it says, and this is a bit over the top, but for those people that really don't like statistics but have done a quantitative study and you're used to writing fabulous lines, this is where we get flowery results. So in here it says, objective considerations of contemporary phenomena compel the conclusion that success or failure in competitive activities exhibits no tendency to be commensurate with innate capacity, but that a considerable element of the unpredictable must invariably be taken into account.
So Linda, you're absolutely right. Difficult to understand. Yeah. Elizabeth lost in the title. Yeah. Very flowery, too many words.
Yes, but we get it as well in using words like a greater predictor, for instance. What does that mean? Something's going to be a greater predictor. Do we have other examples of flowery language?
No, so this is a little bit of the reverse of not being specific enough. This is a case where you might be going a little bit over the top in specificity. But again, it's a lot of times it's just simply the words you use. If you're using, a lot of, adjectives and adverbs, an adjective may actually be translated into a variable. But if it's just simply another fancy word, a lot of times you can eliminate those. So word choice is actually pretty important in these cases.
Yes, because even if we think of, if we're going to say one is better than the other, I mean, once again, we believe that the women are going to do better than the men, of something like that. That might be our own bias, but if the literature suggests that, then okay. But again, we need to be very sure when we are writing both the research question and the hypotheses that do we really have one tail or two tail when we write that?
Well, you make a good point too when you use words like better versus different. So again, those words actually matter because better or greater or higher than implies one direction. So you would be using a one-tailed test versus different, which could be both ways, and it could be a two-tailed test. And a lot of times, frankly, some very large, expensive studies have literally come down to, did we use one tail or two tail? And so again, you don't want to put yourself in that position. If it can go both ways, it needs to be two-tailed. If it really can only go one direction, then you may have to consider a one-tailed test.
But it has to come from your literature where You know,
Absolutely.
it's like for instance, if it says absolutely there's 100 chips in the Pringle containers, and the literature says, oh no, they're ripping us off. There are not 100 chips in the Pringle potato
Hmm.
chips. Then that's a one tail on the negative side.
That's right.
If it just says we're not sure that that's true,
Hmm.
then okay, then we need to have the two tail. And I know that the other side of this is that once you write the hypotheses, the null, it's okay to write it exactly the same for the alternative, but just changing the not to is, or whichever you need to do. You don't need to look for an adjective or a synonym to change the expression. In statistics, it's okay to be boring and precise. Well, not boring, actually. I shouldn't have said that, should
Hmm. No,
I?
that would never be the
Okay.
case.
No. So first of all, the mistake here. So among adult citizens, do those citizens who vote less frequently have lower levels of voter participation? Well, I think there's a question. I think the question has some problems. Yes, it's cyclic, right? Because it's saying we call them in logic tautology, that all the answers are yes, are true, right? And we're saying that for those people who vote less, they vote less.
Right.
And that's what this is saying. So do those citizens who vote less frequently have lower levels of voter participation? So you need to be careful when you write that you haven't basically answered your own question on either the sample that you've got or the way that you've worded it.
Well, and in some of the statistical tests, collinearity can be a problem. So if one variable is really, kind of the same as the other variable, then you're actually violating an important assumption for doing the test itself. So it's really important many times in statistics that the two variables are independent of one another. And I think that's being violated here.
And another good example would be, say, multiple regression, where you've decided, I think one of the questions they had in one of the quant classes was they were finding out how much models got paid. And they included the number of years of modeling and the age of the model. And those two things, not always. I mean, Twiggy made lots of money when she was young. But in most cases, as people get older and more professional, then they would end up making more money. And so those two variables don't just glide along with the stats. They actually make a mess of the stats, and one of them needs to be removed. It's not just, oh well, it's okay, they'll both have the same coefficient. That's not what happens. Well, we've received, does caffeine make women think differently than men? So what do you think the hypotheses would be? So let's start by, what's the hypotheses? Would we say that men the men and women think the same? Will the alternative be men and women do not think the same?
You make a really good point about the hypothesis. A lot of times people get confused and kind of flow right over the null hypothesis. So a lot of times what I found is it's really important to first define what that null hypothesis is, that they don't think differently, and then flip it into an alternative. Sometimes we go right to the alternative, and frankly, when we're doing our statistics, we're testing the hypothesis, but we're using probability to reject or not reject the null. So it's always important to define what that null is.
Okay, and so let's assume that we write that women think differently from men. Usually we continue in the hypotheses as stated by, or as proved by, or using such and such a test. So how would we do that here? We would have to have some sort of thinking test.
Well, it looks like you'd have to have a thinking test and a caffeine test.
Absolutely. Is chocolate caffeine the same as coffee caffeine?
Well, and even going back to my earlier presentation. Is caffeine a category? So caffeine, yes or no? Is it high caffeine, low caffeine, moderate caffeine, or is it literally like cups of caffeine or even milligrams of caffeine per day or per week or per year? So all of those things matter in how you're determining what type of statistical analysis you have available to you.
And not only that, I mean, I think we think differently than men anyhow. So caffeine or not. So this would be even more difficult with such an open question as this. It would need to have something, does caffeine affect women more than men by some, say, heart rate? So where we would then be testing to see if the heart rate increased when women drank, say, 2 cups of coffee compared to men. So in this particular case, we do have two groups. We could use a NOVA or we could use a t-test, but the difficulty would be in deciding, as it says here, the independent and dependent variables and what we would use to judge them. And this is a really important one. You know, tests that say, do we believe that professors are wives are more likely to perceive their husbands as being unfaithful? Well, that whole, as soon as the word perceived comes in, it's difficult then. How are we going to judge that? How are we going to have a number? My answer always is, what's the number that represents this? That we represent. So I know the Likert scale has made lots of these things capable of being quantitative, but we still need to be sure that it's a reliable and valid test that we're using. And there are many factors, and that's another difficulty when you put two factors in one research question. We have to be careful then that which one are we really talking about?
Yeah, and that's where we can introduce confounders and even effect modifiers. There's a lot of things that could be going on here. A lot of times, starting, with simple, and then, building on that simplicity first, like you said, even do men and women think differently? Does caffeine affect certain biological factors? And then based on those studies, then look at, what makes sense to move on to the next type of study.
But even in here, if we added something like, does your choice of political party depend on age and education? And now you've got age and education in your story, but they're not the same when you go to write them out in your research question. Yeah, there's all sorts of things wrong with this one. It just needs to be narrowed down. Ways of being able to consider people thinking differently. The amount of caffeine needs to be defined. What the caffeine is. Pre and post tests for sure. So this is a general question, and probably the most common error here is, if you can answer it with the answer yes or no, you might want to think again. Okay, so here's another icing the kicker. Does a timeout by opposing coaches just before the kick in a football decrease the chances of the kicker being successful? And again, this is a yes or no answer, so it would be totally, well, and Maria, you're saying yes. How do you know that? So actually, the answer is right. It is yes. That it does decrease the chances of the kicker being successful. But how would we set this up to show this? There's nothing wrong with the research question. It's just now, what kind of sample would you use?
So we have Janet says pre-test or pre and post test.
Yeah, I'm not sure about that, because in this case, Well, we could have a pre and post test, but we could just have a group of kickers, right? From, I
Yeah.
don't know enough about football, but we could have, you know, not all the NFL ones, but we could decide on doing a month, right? And seeing the times that they were, there was a timeout by the opposing coach compared to
Well,
the times that they were getting.
and despite your football preferences here, again, the variable definitions are important. So you could have icing the kicker as yes or no, and then you could have the kicker kick, so then success being yes or no. So were they iced, yes or no, and were they successful, yes or no? So that seems like possibly almost like a 2x2 table.
Yes.
What are the
Or
thoughts from the audience?
or
Yeah.
what about the group being like so you would have the success and the non-success, but you would just find out the proportion of each. It would be a proportion.
Yep.
Uh,
Yep.
and you could proportion one person, but that's not a really, that sample might be a smidgen tiny.
So one thing I'm seeing in a lot of the responses, Sarah, I think is also a pitfall. A lot of you are looking at other factors. So you're looking at, were they, football versus basketball? Were they, what types of kickers were they? American football. So go back, and I see this all the time in tutoring, Sarah, where the student has gone several levels above what the question is actually that's being asked. So go back to what is the actual question. So we're not talking about American versus Australian football. We're not talking about left-footed and right-footed. We're not talking about any of these other factors. We're really breaking this down to were they iced, yes or no, and were they successful, yes or no. Sometimes I think we confuse ourselves by getting more complicated than what the question actually is.
Absolutely. And that in here, that's what I was saying. We could just choose a team. Or one person is not enough, and that's obvious that the sample would be a way too small. But we need to be clear when we write our research question that that's what we're talking about as well. That if we have a large population, and it would make a difference on who we're talking about. I mean, is it high school football? Is it professional football? So in the question, we need to be sure that we have isolated correctly.
Yep.
So that's another pitfall when we talk about anything that could cover a wide range, and maybe age is a variable, but we need to identify that as well. So the question's not whether yes, the question was whether they were iced, but the meaning is, do you believe that if a timeout is called, that causes the kicker to not perform the same way?
So when we go back to dependent and independent variables, so the dependent variable is the outcome. So it's success, the success of the kick. And the icing is the independent variable. So again, think statistics, think variables, think, what are my variables here? And that'll help you determine what type of test you're using.
And you could think of it as a correlation. Is there any correlation between the number of timeouts called before the kicker kicks and the kicker?
Mm-hmm.
And that would answer the question about the experience of the kicker. Because if we had 30 kickers in our sample, and we were seeing if there was any correlation between the number of times they were iced, as they call it, and the number of successes or the points scored, which would be the same idea. So we would be able to narrow down and have a statistically significant answer for that part as well. Pat, I've sort of run through my, I know I'm supposedly facilitating, but are there more questions that are out there?
Well, let's open this up to the audience via the chat, and let's ask. We've kind of teed up a few kind of our favorite pitfalls. Let's see what pitfalls the audience has experienced as well.
Okay, so why don't we just look at what is the relationship between strategic and financial planning and small business success beyond 5 years? My first question would be that you put strategic and financial planning in the same sentence. Does that make sense? That strategic and financial planning, unless you have some way of testing, and how have you gauged? How are you going to say that some small business is successful? And I know you just wrote. I'm not picking on you. I know you just wrote what you're doing, but it's good for you to be thinking, what will the numbers be? So what you're saying is, do they do a plan or they don't? Or is there levels of good and bad plans? Were you thinking of chi-squared, where they had a plan, they didn't have a plan, they were successful, or they weren't?
And feel free others to just comment via the chat on things listed in the pod on the right, or just other things that have maybe come up even during the presentation that you're now thinking about.
And how does receiving financial aid affect the eventual employment status of students, using an SES as a composite measure?
And I think this is a good time also to reiterate, we have our tutoring services. Clearly we're not going to be able to answer all of these questions. These are great questions to pose, obviously, if you're working on your dissertation, to your chair and your committee, but also making an appointment with the tutoring. We can really help you, kind of narrow down some of these questions.
And I see Gabriel's got a question about chi-squared. Well, there's a couple of things. It says non-parametric. That means that we don't need to make it, we don't have to worry about the normal distribution. But usually we use it if we were going to compare something categorical. So we might say, does where you live affect your favorite drink? So we might interview people from New York, New Orleans, Washington, and then offer them, do you want beer? Getting us.
It's back. Yep.
Yeah, I don't know. I just saw the little green thing not flipping. So we would be saying, is there any relationship between where you live and what the favorite drink is? So that's, I mean, that's one example. Many of the ones that are used is there any relationship between how male and female do on certain tests? And you can have a huge matrix. It doesn't have to be 2 by 2. On the test, you could have A, B, C, D, and F, right? And then you could have male, female. You could do race. You could have, however you want, or age ranges on whatever. The thing about chi-squared is that once you're done, all it says is, yes, there's a relationship, or no, there isn't. So it's not really a deep statistical, when you're done, that you're just going to say, yep, well, yeah, it matters where I live. I'll likely be drinking beer. So that's, you see, or I'll be drinking hot chocolate. So that's probably not one to be looking at.
Sarah, we've talked a lot about variables. Another pitfall that's come up is just the power and sample size. It seems like some people really struggle with how to figure out even is this powered correctly? How many people do I need? You mentioned earlier having too few people in your study. Any additional comments on that?
Yeah. Yes, absolutely. And there's G-Power, which is downloadable, and there's a Dr. Zinn actually did a video that's in the Academic Skills Center on how to use that to be sure that you have a big enough sample to get the effect that you need.
Mm-hmm.
Yeah, so that needs to be done first. So if you're going to look at something that requires a large sample, maybe that's not possible. I was comparing students at a college, and I just basically slipped under the wire for the number that I needed because they happened to have 2 extra classes the semester that I was doing it. Otherwise, there would not have been enough students in the class.
And a key factor in really in all statistics, but especially in power and sample size, is the variability within the data itself. But also then in power and sample size, what you're trying to do is determine the effect size. So you want to try to predict, that prediction is going to come either from the literature or from a pilot study. If you're looking for like a change in a mean, how much of a change is it going to be? Is it 10%? Is it 5 points? It's important to be able to be as precise as possible on that. Of course, it's an estimate.
Okay, and I'm going to go on to another one I see here. Blessing is there an association between nurses and patients' attitudes towards abdominal hysterectomy and the attitudes towards post-op? I can't see the rest of the question. But that word attitudes is, unless you already have a valid and reliable test to use that will give the nurses and the patients a score. That's very difficult to do in quantitative research. And I see that Blessing says she's found an instrument. That's great. So when you write the research, I know you're just writing it for us now and didn't want to be writing forever, but that's perfect. If you have some instrument that measures, that makes, well, it's perfect. That's and the question that says how many contributions have been made in the fashion industry by indigenous, and I'm just guessing, but again, the answer could be 6. So you need to be sure that when you write this research question that I can't answer with just the answer yes or no or the number 5 or whatever. What are the effects, or what are the contributions, or something of that kind, so that you be sure that you can't answer just yes or no or with one word.
So Sarah, I think, to summarize what I've heard you really making a point of in this session is planning. So a lot of these, not all of them, sometimes we get surprised, but a lot of these could be avoided or mitigated by planning, really thinking through, what am I doing? What are my variables? What is my research question? How am I going to operationalize this? The last thing you want to be doing is trying to figure this out after the fact. That's just not a good place to be.
Yeah, and I'd like on that point, I'd like to say that when you send something into IRB, it's not their responsibility to find out if there is, like Blessings found this instrument. It's not. They're not going to check that instrument's going to do what you say it's going to do, or what you want it to do. So if you have this illusion that as you send this paper along, someone is going to check it's your responsibility to be sure that you have a way of testing, and that you are going to use the test that you say you're going to do, and that your data can survive the test of the tests, basically.
Yeah, exactly.
That's a difficult one, and when we talk about it's a bad word, assumptions. It sounds like, oh, we're making this assumption, but basically what it's saying is your data good enough for the statistics to be done on it? If you're going to choose this multiple regression, is it good enough? And that's how you should see it, so that when you look at all the assumptions, that you're sure that they're going to have a check mark beside each of them. It doesn't mean, oh, I'm assuming they're okay. It has nothing to do with our word assume. It has all to do with, is our data good enough? And certainly all the tests have a list of assumptions, and I would suggest that you start looking at those at the assumptions for the tests and have a look at some of the tests that are out there, how you're going to collect the data. You don't want to do a 5-year study. You know,
Right.
a longitudinal study, as clever as that is, you might want to get the letters after your name first and then, you know, do the longitudinal study afterwards. So.
Absolutely. Absolutely. Yep.